Okay. Explaining the language in the question so you understand it. Expand, of course, as we learned last lesson, means get rid of the brackets. Like just get rid of them completely. Binomials is a new word to you. Okay. Binomial means two for bi, like bicycle, 2 cycles, like 2 wheels on your bicycle. Tricycle has 3 wheels, right? So bi means 2, and nomial means, well, number, okay? Because each of these brackets has 2 terms in it, or numbers, right? So each one of these brackets is called binomial. That's a binomial, that's a binomial. So expanding binomials, fancy way of saying expand these 2 brackets, and collect any like terms. So we'll discuss that as well if they come up. First, I'm going to think in my brain, just looking at the algebra, thinking in my brain this rectangle. If it helps you, please feel free to draw this rectangle and instead of 4, y, 7 and x, replace them with x, 4, 3 and x. Hopefully you'll get to a point where you don't need that, but if it helps you for the moment, please do. I'm not going to do it because I have a reference, but I'm going to write this x is going to be times by both of these numbers. Because these are like my 2 heights, my 2 widths, and x is like one of these. So I'm going to represent this as, first of all, x times both of these. Then I've got, coincidentally, another 4. 4 is also going to be multiplied by both of the widths. So I'm going to have plus 4. Lots of 3 plus x. So this is like my top 2 rectangles, my bottom 2 rectangles. Now I need to just expand single ones, like we did all last lesson, right? So I'm going to go x times 3, x times x, 4 times 3, 4 times x. Which should be pretty straightforward. I'm going to get x times 3 is 3x. I need more space. 3x, x times x is x squared. Then I've got plus 4 lots of 3 is 12. And 4 lots of x is 4x. Now looking carefully, we have 3x and 4x are like terms. So we can add them. We have 3 lots of x and 4 lots of x, which makes a grand total of 7 lots of x. So we're going to get x squared plus 7 lots of x plus 12. X squared is not the same as x. I can't say that this is 8, like this and this and this is 8x squared. Can't say that. I have 3 lots of x, 4 lots of x, and 1 lot of x squared. Can't add the x squared to the x, so x squared will just stay by itself. And typically, yes, they're both x's. This power is bigger, so we write it first. Yeah. Let's go with y plus 2, x minus 1. So we're going to get y times these 2 widths. Y lots of x minus 1. And then the 2 times those 2. Then we expand by multiplying and multiplying, multiplying and multiplying. And we've got to be careful here, we've got some negatives involved, so we'll think critically. Y times x is just xy, alphabetical order. Don't forget. Y times minus 1. Well, let's worry about the minus later. Y times 1 is just y, but I've got a positive times a negative, so the answer will be negative. Then I have 2 times x, which is 2x. And finally, I have 2 times 1, which is 2. Positive times a negative makes that a negative answer. Now, this has a y and this has a y, but this also has an x, which means they're not the same. Similarly, they're not the same. Even though they've both got x's, this one's also got a y. That one doesn't have a y, they're not the same. They're not like terms, so I can't combine anything here. So if you want to get super technical, I could write 2x before the y because of alphabetical order, but it's not necessary. If you want to, feel free to. But that's it. So this is called expanding binomials, or expanding brackets when you have binomials. And it's still the distributive law, that fancy way of saying expanding the brackets like we did yesterday, but it's for when you got a double bracket.